Hey there, Math 8. Have I got some good news for you guys? Today is the last notes of the year. Huh? So enjoy. I think they're good. I think you'll understand them. Here we go. So up to this point in the chapter, we've learned a few important things. We have learned several pairs of angles and how they relate to each other. You know, one thing we did was vertical angles. Vertical angles are like these two, when two lines cross and they are equal to each other, right? And we also learned the hardest one for most people, and that is the linear pair. Guys, a linear pair is when you have a line and then you have a point on that line. And at that point, you split the line into more than one angle. Like that would be two angles. That is a linear pair. At that point, you have made two angles out of that line. And this would work for three angles, or I could make a third angle too if I wanted to. But the bottom line is all of those add up to 180 degrees because a line is actually a 180-degree angle. All right, and then we learned a couple more. We learned that when two lines cross, these two guys are called alternate interior angles. Or these two guys are called same side interior angles. Or these two guys are called corresponding angles. And when these lines are parallel to each other, right, there's a little parallel symbol, these guys are equal. These guys add up to 180, and these guys are equal. Those are the angle pairs we've learned so far. And then we learned a couple basic things like inside a triangle. I start that right now, so let's just do it. We know that in a triangle, the interior angles, so that would be like these three, right? The three angles inside the triangle will always add up to 180 degrees. So we're going to add one more thing today, and that one more thing is, but what is an exterior angle? An exterior angle, this is how you make it, is made by extending one side of the figure. So for example, I might take triangle. I'm going to draw a triangle here. And you might want to put these letters where I put them. So A is going to the side there. That's point A. And for point B, I'm going to put it below point B. And I don't have a good place to put point C. So I guess I'll put a small little C right there. Okay. So I've got triangle ABC here. And I'm going to make an exterior angle. It is made by extending one side of the figure. It is the angle made by the extended line and the other side of the figure. So we're going to take this triangle and we're going to extend side BC. So BC is the bottom. I'm extending it. And I have made an angle here. I have made this angle. I'm going to put it in a different color just for the heck of it. I have made this angle right here, which I'm going to call angle 1. Notice that that angle is made by the extended line, BC, and the other side of the figure, AC. I didn't make it down here at the bottom, underneath it, on itself. All right, that is an example of an exterior angle. I guess I noted that here, right? Angle 1 is an exterior angle. Now, at each vertex or corner of the triangle, you could make two exterior angles. right? I could make another exterior angle also at point C, like this. We could also extend side AC. So I look at side AC of the triangle, and I extend it, and make an exterior angle that we will call angle 2. So I'll call this, where the C is down here, I'll call this angle 2, right? Notice that the measure of angle 1 and the measure of angle 2 are equal. You guys know why those two angles have to be equal to each other? I'll bet some of you do. That's right, it's because they are vertical angles. And vertical angles are always equal to each other. And so typically, because those two angles are equal, typically we look at just one exterior angle at each vertex. Even though technically you can make two of them, we really only talk about one exterior angle at each vertex. And I want you to notice something else. So there's another angle here, angle 3. Angle 3 is not an exterior angle, right? And I explained why, because it is not made by extending just one side of the triangle. It's made by extending both sides of the triangle, and then it's like between them. That is not an exterior angle. So I thought, just for practice, we ought to draw an exterior angle at vertex A and B. And that would be done like this, right? All I do is extend one side. So maybe I extend this side, and that might be angle 4. Maybe I extend this side, and that would be angle 5. And an angle 4 and angle 5 would be an example of one exterior angle at each vertex, right? Angle 4 is the exterior angle at B, and angle 5 is the exterior angle at point A. All right, really easy, right? You don't need to do this, but look, you have a triangle, you extend one side, you extend another side, you extend another side. There are your 3 exterior angles. It's that easy. I think that takes care of that. So, hopefully now we know what an exterior angle is. You can see I have a diagram here. We know that a triangle has 3 interior angles inside it, right? Interior means inside. In the diagram, this would be angle 1, 2, and 3. We have a name for these, right? So we're going to take these 3 interior angles, and we have a special name for each one, based on where they sit compared to the exterior angle. So in this case, of course, angle 4 is the exterior angle. Now I have names for these ones on the inside. The interior angle that sits next to angle 4 is called the adjacent interior angle. All right? The word adjacent means next to. And that, of course, is angle 3. So this angle right here is the adjacent one. The interior angles that are not next to angle 4, we call them the remote interior angles. And of course, that would be angle 1 and angle 2. These guys would be the remote interior angles. So for any exterior angle The interior angle next to it is the adjacent one, and the ones that are not next to it are the remote interior angles. That is the end of the vocabulary lesson. Let's see how that helps us. So there are two relationships that involve the exterior angle. Both can be used to help you find missing angle measures. This first one is called the exterior angle theorem. In a triangle, the measure of an exterior angle, right? This guy is the exterior angle, will always equal the sum of the measures of the remote interior angles. And of course, we know that that these guys, right? These guys are the remote. Huh. So in this diagram, that means that the measure of angle 1 plus the measure of angle 2 will equal the measure of angle 4. When I add angle 1 and angle 2 together, I get the measure of angle 4. It's easy enough, right? Let me show you a quick example that uses that, and we'll move on. So here, this angle, of course, would be the exterior angle, whereas these guys would be the remote interior angles. And so I can use this theorem that I just said to calculate x. I know that when I add the remote angles together, the x and the 23, they have to equal the exterior angle. And that is easy to solve for all of us, right? We subtract 23 from both sides. Boom, we get x equals 109, it looks like. And I have done it. All right, so that is the first rule of the day. When you add the remote angles together, they will equal the exterior angle. Next up, our second rule. An exterior angle and the adjacent interior angle will always add up to 180. Do you guys know why? Because they form a linear pair, right? A linear pair, that's when you have a line, and at some point on the line, you split it into two angles. That's what a linear pair is. And look at the diagram. That's what we have. This is the exterior angle, and this is the adjacent interior angle. And together, at this point, they form a line. And that line has been split into two angles at that point. So in this diagram, the measure of angle 3 plus the measure of angle 4 would have to equal 180 degrees. And here's an example of that being done. So in this diagram, example 2 here, I want to solve for x. The 17 degrees here, that is a remote interior angle, and it is extra information that I do not need for this problem. Because here, I have the exterior angle, and here I have the adjacent interior angle, and together those two angles make this line. They are a linear pair. So I know that x plus 128 must equal 180. And all of us know how to solve that for x. We would subtract 128 from both sides, and we would find out that x equals 52. right? Which brings us to our last example, the most difficult one, of course. And I've made a mistake in this one that's tragic. So let's go back here. And let me just tell you the mistake first. This angle has been named incorrectly. This should be the measure of angle QPR. Sadly, I named it wrong. All right, so here we go. Let's do this problem. In this one, I have to draw a diagram. So we're going to practice reading the problem and drawing a diagram. So I have triangle PQR. Let me draw a triangle, and I will call that triangle PQR. I like to put little dots at the corners. Okay. And it says that PR is extended. So let me take side PR and go ahead and extend it through R to point S. Ooh, I'm supposed to put another point down here, S. So I've taken side PR and I've extended it through to point S. And now it is giving me some angle measures. Angle QRS. So starting at Q to R to S, that's this angle right here. That is 11x minus 7. Okay, and what type of angle is that? That is an exterior angle. It tells me that, I'm going to change colors. It tells me that angle RQP, so that's this angle right here, RQP, yes. That angle is 3x plus 17. And angle QPR, that's this angle up here, that angle is 3x plus 11. Okay. So in this diagram, what it has told me, it has given me these two angles, which of course are the remote interior angles for this exterior angle. So I can use the first rule we learned today, which is when you add the remote angles together, it will equal the exterior angle. So my equation might be 3x plus 11 plus 3x plus 17 equals, so my two angles added together equal 11x minus 7. And now I have an equation to solve. Add my 3 x's together, add my 17 and 11 together. If I were doing this now, I'd probably subtract 6x from both sides. And if I were doing this, I'd probably add 7 to both sides. And finally, I would divide by 5, and I would get x equals 7. But the important thing is you learn the rule to set up the equation. All right, that should do it. I will see you guys in class tomorrow.